All right, welcome back. Now we have a question, and we are told that a wheel rotates with a constant angular acceleration of 5 rad per second square. And we're told that if the angular speed of the wheel is 3 rad per second at t equals to 0. T equals to 0 is simply that when it was at rest. Now we're told that through what angle does the wheel rotate between t equals to 0, that is when it was at rest, and t equals to what, 4 seconds, that is when it has started what, rotating. Immediately it starts rotating, this time starts what, ticking. Now we are told that what is the angular speed of the wheel at t equals to 4 what, seconds. Now whenever you are given a question like this in physics or in mechanics generally, what thing that should come to your mind is that what are the parameters in the questions. So the first thing you need to do is to bring out the parameters. The parameters will give you an hint on the right formula to use to solve that particular word question. And when bringing out the parameter, always take note of the word of the standard unit, which is the SI unit. Now for each of the word, for each of the quantity. Now from here we're told that a wheel rotates with a constant angular acceleration. The symbol for angular acceleration, now solution. The symbol for angular acceleration is what, is alpha. Okay, let me just stay there to this place. We are giving our alpha, and alpha we are giving it to be what, 5 rad per second square. Sometimes they may not make use of the word a constant angular acceleration. They may just tell you that a wheel rotates, okay, with a speed of 5 rad per second square. Even with the unit rad per second square, you know that they are referring to what, alpha, which is what, angular word acceleration. Now we're told that if the angular speed is omega, that is your W. You can call it angular speed, you can call it angular velocity or angular frequency in terms of oscillatory what, motion. Now of the wheel is 3 rad per second. You can see the SI unit is what, rad per what, per seconds. So we're giving our omega to be 3 rad per second at t equals to 0. That is when the time was at rest. We're giving our, which is, I can call that my word W1, because at t equals to what, 0 or second, that is when it at rest. Now we are told that through what angle, whenever you hear the word through what angle, it's stating as what, as changing what, changing theta. Okay, so number one question, we are looking for what, changing theta, that is theta 2 minus theta 1. Through what angle does the wheel rotate between t equals to 0 and t equals to 4 seconds? When it was rotating, what angle does it move when the time was at 0 to when the time was at 4 seconds? Okay, so your t1 is when the time was at 0 and t2 is when the time was at 4 seconds. When you subtract, then you get your what, omega. Then the next thing, we're getting our t when it's what, at 0 and t when it's what, at what, 4 seconds. So we also have to look for angular speed of the wheel at t equals to 4 seconds. We already have our W1. That means the next angular speed you have to look for is what, is W2. So these are the parameters in the question. And in the first one, we are asked to look for what, for theta. The first thing that comes to your mind is what are the formula for theta. And in my previous video, I gave you theta equals to distance over what, r. Okay, and if you observe in the question, we don't have anything like distance, neither do we have anything like for radius. That means there's no way this one will work out. I also gave you theta equals to W2 plus W1 all over 2 times t. And if you observe this very one, okay, we have our time, then we have our W1, but we don't have W2. There's no way you can be looking for two unknown value at the same what, time. So that is why this formula will not be what, possible. Then the next one, I also give you theta equals to W1t plus half alpha t squared. And in the question, we are giving our alpha, and we are giving our what, omega, and we are giving our time. Definitely this formula can what, work out. All right, now, so the first step now, I have to look for my theta 1, I also look for theta 2, then I can now subtract the values to get my change in what? Theta. Now to get my theta 1 is stating as W1T plus half alpha T squared. Alright, so our theta 1 becomes, our W1 is stating as what? 3 times our time, that is when our t was equals to 0. Okay, so definitely our time is 0. Then plus half. Then alpha was going to be what? 5. Then times time. Okay, which is 0 was squared. So our theta 1 becomes 3 times 0 will give us 0 plus half is sitting at 0.5 times 5 times 0. So theta 1 becomes 0 plus 0. So we give us what? 0 rad. Okay, so when the time was 0, my theta 1 was 0 watt rad. So you also look for when the time was what? Was 4 seconds. So when the time was at 4 seconds, it becomes theta 2, okay, equals to W1T plus half alpha T squared. Okay, so from here, our theta 2 becomes, our W1 is sitting as 3, then our time is what? 4, then plus half, then times alpha is sitting as what? 5, then time y time is what? Time is what? 4, which is 4 squared. So it becomes theta 2 equals to 3 times 4, we give us what? 12. Then plus half is sitting at 0.5. Then times 5, then times 4 squared give us what? 16. So our theta 2 becomes 12 plus 0.5 times 5 times 16. So it's going to give us what? 40. So our theta 2 give us what? 12 plus 40 will give us what? 52 rad. Now to get our change in theta, okay, our change in theta becomes theta 2 minus theta 1. So change in theta becomes theta 2 minus theta 1, which is 52, then minus 52 minus what? Minus 0. Change in theta become what? 52 what? Rad. So that is our number 1 answer. Okay, so the next thing now is to look for number 2, which is our what? W2. All right. All right, so look for W2. Okay, remember I gave you a formula that alpha equals to W2 plus W1, then all over T. So we are looking for from W2. So from here I can get my W2. I have my W1, I have my alpha, and I have my time. So from there, my alpha is sitting as 5, then equals to, and W2, which is unknown, then plus, when the time was 4 seconds, don't forget, they say what is the angular speed of the wave at t equals to 4 seconds. So we're giving our time to be 4, and our W1 was given to be what? 3. Okay, what do? You cross multiply. It becomes W2 plus 3 equals to 5 times 4. So W2 then plus 3 equals to 5 times 4 will give us what? 20. What do? You call that what? Like things. Sorry, this one is negative. I'm sorry. So it's W2 minus W1. This formula was gotten from here. A equals to B minus C over T, where A is sitting as alpha W2 minus W1 over time. Okay, so I'm very sorry for that little what? Error. Alright, so from here, so what do? Is to collect what? Like terms. Collecting like terms, it becomes W2 equals to 20. Whenever your negative sign is crossing equality sign, it becomes positive. It becomes plus 3. So our W2 is going to give us 20 plus 3 will give us 23. Don't forget the SI unit is what? Rad per seconds, which is rad per seconds. So that is our answer. Okay, now if maybe you don't want to use this very word formula, I also give you other formula that relates to W2. The truth is, whenever you are applying a formula, as far as the parameters are there, okay, in that particular word formula you have to apply, you must arrive at the same word answer. I also gave you theta. I gave you theta. Okay, I gave you W2 square equals to W1 square plus 2 alpha theta. Alright, so from there, our W2, okay, our W2 becomes how many? That's what we are looking for. W2 square equals to, then W1 square. W1 square is 3 square, then plus 2. Then alpha is what? Alpha is 5, then times theta, which is what? 52. That was what we got before. So from there, our W2 square becomes 3 square, will give us what? 9, plus 2 times 5, which is 10, and 10 times 52, so we give us what? 520. So from there, our W2 square become what? 529. Now to get W2 square root of both sides, W2 becomes what? Square root of 529. So our answer becomes square root of 529. We give us what? 23 what? Rad per what? Seconds. So that's it. Now if you don't want to use that as well, then or I also gave you a formula again. I gave you theta, then equals to W2 plus W1 all over 2, then times what? Times T. So our theta becomes what? Our theta becomes 52, then equals to W2 is unknown, then W1 is what? Is 5. Sorry, W1 is 3, then all over 2, then times time, when the time was 4 seconds. So it becomes 52 equals to, use 4 to open all this, we become 4W2, then plus 4 times 3 will give us what? 12, then all over 2. What you have to do is to what? To cross multiply. By cross multiplication it becomes what? 52 times 2 equals to 4W2, then plus 12. So from there, 52 times 2, which is going to give us what? 104. 104 equals to 4W2, then plus 12. By collecting like things, we have 4W2 equals to, then 104 minus 12. 4W2 will give us 104 minus 12 is going to give us 92. To get our W2, divide both sides by 4. 92 divided by 4. So we give us what? 23 rad per second. So there are so many ways to kill a bird in physics. That is when you know the formula. Okay, applying it is very what? Easy. So you can see, using 3 different formula, we arrive at the same what? At the same what? Answer. So that's physics for you. All right. So let's move down to the next question.